Graph D is another piecewise, so we're going to treat it in the same fashion. So I'm going to look for what kind of functions I'm dealing with to figure out the domain, and then make sure that all of my points are accounted for, okay? So let's just look at what we've got. So this graph right here, x squared minus 1, is a parabola, okay? So parabolas on their own are continuous, okay? So if that graph is continuous and it's everywhere that x is less than -1, I know I'm going to have this goes to the left, and this is an open circle, okay? So that's what I know about that piece of the function. This graph is just 2, and it's at x equals 0. So that tells me this is a point. So this is just a point, okay? And it's at x equals 0. Okay, well, I'm starting to see a problem because it looks like from -1 to 0, this function doesn't have a piece for the piecewise. So that tells me that there's going to be a problem, okay? This piece right here is a line, and it's a line where x is greater than 0. So line where x is greater than 1. So this is going to the right because it's greater, and it's open because there's no or equal to. So it looks like this function exists from less than -1, so -infinity to -1, has a break between -1 and 0. There's a point at 0, and then there's a break again between 0 and 1. Okay, so that means there's a couple of issues in the domain. So this first piece goes from -infinity to -1, but because it's open, it does not include the -1. And then there's a point at 0, which is included because it's actually a point, but it doesn't go further than that, so it just goes to 0 again. And then it goes from 1, but not including 1, to infinity. So that would be the domain of this graph. From -infinity to -1, there's a break between -1 and 0. It includes the point at 0, and then there's a break until 1, which is not included, and it goes to infinity. All right, so checking end behavior. Okay, so end behavior, so the left, so the limit, well, I did positive infinity last time first, so let's keep it consistent. Let's do positive infinity this time first. So as we're going to the right, this function is on this arm. This arm is a line that has a negative coefficient. So as we go to the right, this function is going down. So this function is going to -infinity. As we go to the left, okay, as we go to the left, this function's on this arm. This is a parabola. It's a parabola with a positive coefficient, so it's going up for both. So this is going to positive infinity. Okay, so it's going to -infinity on the right, positive infinity on the left. Okay, the x-intercepts. X-intercepts occur anytime you would set it equal to 0. So if I've got x squared minus 1 equals 0, I'm going to set each piece equal to 0. So if I set this piece equal to 0, I get x squared equals 1. So x equals, if I square root, I get plus or minus 1. But neither plus or minus 1 is on that piece of the function. The -1 looks like it would be, but because it's not or equal to, it's not included. So that's not an x-intercept. This point at x equals 0, this point is at 2. So I couldn't set 2 equal to 0. That's not a thing, so I'm not going to include that. And then the other one, -3x minus 3 equals 0. So -3x equals 3. So x would equal -1. But again, that's not on that arm. So there are no x-intercepts. Okay, the y-intercept is where I plug 0 in for x. Well, the only place that 0 exists for x is this one. And where x is 0, y is 2. So the y-intercept is 2. Okay, looking at the next thing, symmetry. Okay, well, on this half of the function, I've got a parabola, then I have a random point, and then I have a line. So because I have a parabola on one side of the y-axis and a line on the other side of the x-axis, this is not symmetric. Okay, and then the discontinuities, we need to see if they meet up. Well, looking at the function, we already know that they don't meet up. So this function doesn't meet up with this function, and this piece doesn't meet up with this piece, but they're not really jumps. They're just places that the domain doesn't exist because there's huge gaps, okay? There are huge gaps. So I'm gonna call them jump discontinuities because that's what they are. They're not asymptotes, but they're not really technically anything you would ever be asked about the discontinuities. You would be asked more about the domain of this function. So this function has discontinuities, has non-removable jump discontinuities at x equals -1 and x equals 1, which really, that's kind of a rough question. Like that would never be something that would be asked of you on an AP test or on a test for me because they're not technically discontinuities. So I'm gonna put a star by them because that's kind of a bad thing to call it. So let's take a look at a graph. It's graph D, okay? So until I get to -1, I'm on this parabola, okay? And if I plug -1 into the parabola, that's 1 squared minus 1, which is 0. So at -1, I'm at 0 and it's an open circle, okay? And I know that that's a graph, that parabolas like that come into down here. So I know that this is this arm of the parabola, okay? And then at x equals 0, I have a point at 2, okay? And then at x is 1, if I plug in 1, -3 minus 3 is -6. So 1, 2, 3, 4, 5, 6. So at 1, -6, there's an open circle, and it's a line that has a negative coefficient, so it's going down. So I have the graph of the parabola piece, the point, and the line that's going down.